In this video, I am going to show you how to find the inverse of a logarithmic function. But first, I need to make sure you understand two more basic concepts that we're going to need. The first one is just how to find the inverse in general. So before we get into logarithmic functions, imagine that I had the function, let's say, f of x is equal to 2x plus 3, simple linear function. Now this would be the same thing as y equals 2x plus 3. So to find the inverse function, you do two things. You switch x and y, and then you solve for y. I'm just going to repeat that. Switch x and y, solve for y. So first of all, I switch x and y. So the x goes here, the y goes there, and then I'm solving for y. So if I would subtract the 3, so now I have x minus 3 is equal to 2y, and then I would divide by 2. Okay, so now I have x minus 3 over 2 is equal to y. So there I have solved for y. Now I can put this back in function notation with the f of x, but I need to put this little apostrophe in there. Okay, and I'm going to rewrite it from left to right. So this would be the inverse of function f, and the little apostrophe shows that it's the inverse. So that's the first concept I had to remind you of. How do you find the inverse in general? Switch x and y, solve for y. Now here's the second concept that we're going to need to deal with logarithms. You need to memorize how to switch back and forth between exponent form and log form. So for example, I'm just going to use a, b, and c. If I have a equals b to the c power, this is called exponent form. We have a base and power. Now in logarithm form, obviously there will be a logarithm in it. Now focus on the base, the b. Alright, the base is the key to everything. So in logarithm form, you write your log, and then that base goes here. See how it's hanging low? It is a subscript. So log base b. Now the a and the c are basically going to switch places. So the c is going to come over here, and the a is going to come over here. So exponent form, log form. Alright, you need to be able to go in the other direction too. Let's see, here's something in log form. Say if I have p is equal to log base q of n. Alright, I should be able to rewrite this in exponent form. Now again, focus on the base. The q is the base. So, and I'm going to keep this q on the same side, and I'm going to write it as a base. So in exponent form, you have a base, and it gets a power. Now what power? Now the p and the n switch sides. So the n is going to wind up over here, and the p is going to wind up over here, but now it's going to be the exponent. So this would be the exponent form. Alright, now we're ready to find the inverse of logarithmic expressions. Let's find the inverse of this logarithmic function. So anytime you're finding the inverse, you're doing two steps. You're going to switch x and y, and then you're going to solve for y. So first let's switch x and y. So this will become x equals -5 log base 1/2 of y. So there I have switched the x and the y. Now I need to solve for y. I need to get y by itself. The first thing is to get rid of this -5. I can do that by dividing both sides of the equation by -5. Alright, skirt. Those are gone. So now what do I have? So far I have x over -5 is equal to log base 1/2 of y. So now the only way to get y by itself is to rewrite this in exponential form. So let me just bring down my equal sign. When you convert between log form and exponent form, you always focus on the base. All right, in exponent form, the base is by itself. So I've got a base, and eventually it'll have a power on it. Now, the rest of the equation is going to switch sides. So the y and the x over -5 are going to trade places. So the y is going to be over here on the left side, and the x over -5 is going to come over here, but it's going to be the exponent. So I'm going to have x over -5 as the power here. So this is one form of the answer. Now I'm looking at these, and none of these look identical to this, but let me see if I can get you to see why C is really the same thing. Say if I had y equals 1/2 to the third power. This would be the same thing as 1 to the third power over 2 to the third power. But what's 1 to the third power? Well, 1 to the third power is still just 1. So in effect, you can see that this power, because there's just a 1 here and that's not going to change, I could just write the power down here. So that's what's happening to this problem. All right, because this is just a 1, if I take this exponent and apply it to both of these, the numerator and the denominator, the 1 is going to stay a 1 as the denominator becomes 2 to the -x over 5 power. And of course the little negative sign, it doesn't matter whether you put it in the denominator or out in the front. So in this form, you can see that it's the same thing as C.